Okay, let's give you guys some practice. So find Taylor series. Find Taylor series generated by this function, natural log of x, centered at a equals 1. So press pause and have a go. Okay, so to do this, we would start out with this, a general case where it looks like this, and going through. Well, let's just say this thing here looks like this, and then we would apply this transformation. We would apply this transformation because we want to evaluate it at a equals 1. We would apply this transformation. So we would move this graph across by 1. So now this thing will look like this, something like this. So in order for us to come up with our Taylor series, we demand that the first derivative of this to match up with the first derivative of the blue line. We demand the second derivative of this to match up with the second derivative of this. We demand that the third to match up with the third, even the original t of x to match up with the original f of x. So by us making all these demands, eventually this purple line here will map on top of the blue line. So we would start out with this. We would start out with this, and then apply this transformation, so that will move everything across by 1. So that will then give us this. So to come up with our Taylor series, we would start out with this. So start out with this. We demand that the first derivative of this to match up with the first derivative of this. We demand that the second derivative of this to match up with the second derivative of this. Third to match up with the third. Even the original to match up with the original. So let's say when x equals 1. So really, to come up with the Taylor series, we need to work out these coefficients. We need to find these coefficients. So we need to work out these coefficients. So when x equals 1, if you put this into here, put this into here, put the 1 into here, all these will disappear. All these will disappear. And then remember, we demand that this thing equals this thing. So put this into here. Natural log of 1 will be 0. So this thing here will be 0. So a0 is actually 0. So our first coefficient here would be 0. Would be 0. Now we need to work out a1. We need to work out this coefficient. So at x equals 1, if you in order to obtain this a1 here, we need to demand that the first derivative of this to match up with the first derivative of this. So put x into here and into here. So these will disappear, and then because we're demanding that the first derivative to match up with the first derivative, we've got to put this into here. So that this whole thing here will be 1. So a1 is equal to 1. So what we know so far is that this is 0. This is 1, and then for the next coefficient, we demand the second derivative to match up with the second derivative. So at x equals 1, put it into here. So this whole thing here will disappear, leaving you with just this. To obtain this coefficient, we demand that the second derivative to match up with the second derivative. So we will put this into here. So that would be negative 1. So negative 1. So the whole thing here would be negative 1. So negative 1, and then we're trying to obtain a2 here. So we've got to divide both sides by this 2 here. Well, a2 is actually negative a half. A2 here is actually negative a half, and so on. If you put x equals 1 into here, this whole thing here disappears, blah blah. Then it will then give you this. It will then give you this. So from here, you can see the pattern here. So remember, a0 is actually 0. A1 here was 1. We worked it out earlier. A2 here was negative a half. So this is your negative a half, and so on. So you can actually see from this, you can continue on with the pattern. So here you've got remember it was 0. It was 0 and then plus, and then this thing here was 1. So this thing here was 1. So it's plus, negative, and so on. Well, you can follow this whole pattern. You can take it all the way to infinity. Well, you taking up well, if you were to get a graph plot and plot the first the well up to the power of 4, it will then give you this. So this is your Taylor series. Okay, take it all the way to infinity. Okay.